lecture we discuss about multiply two 8-bit numbers with repeated addition method and finding the largest and smallest number between two numbers, which is given 9000 and 9001x. Okay, so first our task is repeated addition method. So what is repeated addition? We know that we multiply two 8-bit numbers using repeated addition. So what is the algorithm? Say for one number is 4, another number is 2. So multiply of these means we addition 4 2 times. So that's the result is same. That means 4 into 2 equal to 8. So this is same for true for say example 4 into 3. Then the answer is 0C because the answer is not 12. Students, the answer is not 12. Why? Because 8085. Yes, right. It's in a hexadecimal form. So that means we add 4 3 times. So this is equivalent to 0C. So that's why it is known as repeated addition. So we repeat the addition of this 4 depending on this number. Okay. So here 2 means we add 2 times. Here 3 means we add 3 times. Say another, for example, 5 into 6. So here 5 into 6 means addition of 5 6 times. So that's why the program is named as repeated addition method. Okay, and there is a provision of carry. Okay, we consider provision of carry. So what we will do that first? So first, in this programming approach, we cleared the C register for carry to store the carry generation, and then say example 2 numbers are stored 9000 and 9001. Here this is the first number x and this is the second number y, and after this in 9002 the sum is stored. That means there is a product, and in 9003 the carry is stored. Okay, so now first LXI H 9000. So the HL pair content is x. So now shift this number in the accumulator, and then INXH is performed, and after this move this number in a B register, say for example, and then addition operation is performed. Add accumulator with itself, and after every addition we calculate jump if carry or not. This is very important. Okay, after addition, and here if jump if no carry is false, then we value increment of C. Here C register is C equal to C plus 1. So C equal to C plus 1, the carry generation. So now if this condition is true and there is no carry, then we decrement the value of B, because this number is, say accumulator is 4 and this number is 2. So now this value is 1. So now check this number, jump if no 0 or not. If this is no 0, this condition is true, then again we addition accumulator with itself. Why? Because 4 plus 4 plus 4 2. Now when this is 0 and this condition is false true, then it jumps to this loop here, and when this condition is false, now we store the number, because in the accumulator the result is stored. So what is our target? Yes, and then carry is transferred to accumulator, and then save it 9004, and then after halt operation is performed. So this is our algorithm of product of two numbers. So now in the assembler, step by step we follow this code: MBIC, 00 first, and then LXI H 9000 hexadecimal, then move A, M, then INXH, then move B, M. Okay, so now here one loop is generated. Now here add A, chain C L1 increment C, then L1 here located, this is DCRB, and then JNZ L2, that is STA 9003, and then move A comma C, then STA and then 4, and after the halt operation is performed. Okay, so now first assemble and load, and we here after this program assembling, we enter the number say 4 and 3. So what is our result? C. Now check out, is it okay or not? So now after the simulation, now this is our log file generation, and what is our answer? Here look that there is a problem in this answer. Why? After this operation, the answer is not because check the algorithm. First move a comma M INX age, then the second number is stored in the B, and then addition will do itself. Yeah, one problem here is that the accumulator content is 4, so this is, so here we take one technique is followed. Here say for example this value is transferred to D, okay, because here one problem arises, because after before addition accumulator content is 4, so this is the extra 4 addition with this, so this is a problematic. So now you M comma D, and after this, and at first here we use XOR A. XOR A means accumulator XOR with itself, that means accumulator equal to 0. So this is the clear instruction of the accumulator. Okay, so now see that add D, accumulator 0 0 with D, jump if no carry, if no carry then decrement B, and if carry then after this operation performed here decrement B, and then is it jump if no 0 then add D here also, and again to 9003, and yes, so on. Now we develop our code. There are some error, I think there are some error. XOR MBI this LXI. Now here move D comma M, INX is move B comma M, this is add D, okay, JNC L1 increment C decrement B, JNC L1. Now again we assemble and load, yes, right, then here we mention our number 4 and then 3, yes, right. Now simulation now take perform, see that there is a log file generation. Okay, now see that, yeah, so now here 9000 we stored the number 9003 and 4, okay, and also this is 9002 and 9003 also, okay. So now here you see that these are answer 0C, okay. So now again assemble and load, simulation start, assemble and load, and then put the number. This algorithm should be either their error is generated. Now start, and after step by step, here students see that there are 2 times of loop jumping here, because until the number 3 equal to 0. So now see that this answer is 03. Okay, now this is okay. So now again we check for the large number. Say for example 1 is FF into FF. So what is our result? So is it okay or not? We see that. Now assemble and load first. Now we put the number FF then FF. So now see that the result is okay or not. That means carry generation is okay or not. So the simulation task is very lengthy, so that's why we here increase the rate extremely fast. So now see that this is a many times of loop jumping, okay. So now we increase the rate ultimate. So now there is a performation of our operation, okay. this takes much more time. And see that, because why these loop are execution time is very large, because the second number is ff. So ff times, that means 256 times the loop is internally jumping, because the number is not 0. Okay, so that's why there is a much more time required for step-by-step simulation, and that's why I changed the rate ultimate position for the first simulation process. So see that the result is 0 1. Yes, so what is our sum value, that means product value 0 1, and what is our carry value? Yes, right. So this is okay. So this is the operation of 2 8-bit number multiplication using repeated addition method. Okay, now in the second part we discuss about compare 2 8-bit numbers, and after compare, first store we larger number and then we store smaller number. Consider in 9000 and 9001, in these two location, two number are stored, x and y, and if x greater than y, the larger number, L stands for larger, the larger number is stored here and the smaller number is stored here. Okay, so we rearrange this number. So compare to it. First of all, there is an instruction in 8085 known as compare. Compare means one number in the accumulator and another is the 8-bit register. This is 8-bit register. Say for example 8-bit register equal to b. Say consider. So now the instruction is compare b. So now there are two condition arises. Student, please follow that. If a greater than b, so what is the status? This is a very important. Then 0 flag equal to 0, carry flag equal to 0. Now what is the status if they are equal? This is 0 flag equal to 1, carry flag equal to 0. And third is most important. If this, then 0 flag equal to 0, carry flag equal to 1. So depending on this flag decision, we can interchange, we can decision our programming logic, different programming logic. Okay, so first we load the number HL content, then it transferred to the accumulator, and then INXH is performed, and then compare between them, compare M. So now here we place JNC instruction. So why JNC, student? This is very important. If jump, if no carry, that means A greater than B. Then we directly store A in 9002 and then transfer the number of B to accumulator. Then this is stored to 9003. This is very easy task, and then halt. But this is one condition is met. But why? What is the other condition? That means if jump if no carry, that means carry is generated. Then accumulator is smaller number and B is small greater than number. Okay. Then we store the accumulator number first in 9003. Okay. And then transfer the then we transfer the larger number from register B to A and then store 9002, just interchange the memory position, and then here we used jump L2, so here L2, that means halt. So this unconditional jump instruction used here. So are you understand this? Yes. When there is a no carry, this instruction is false, that means there is a carry generated, that means in register B is a contain larger number. So that's why here we the first is smaller number is stored in the accumulator in the 9003 first, and then larger number transferred to accumulator and then store it. Okay, so this is a very easy task. So now see in our programming, so now line by line written first of code, write the code LXH 9000 hexadecimal, then move A comma M, then INXH, okay, then compare M, okay, then JNC L1, then STA, then STA 9000H hexadecimal, then move a comma b, move a comma b, then STA 9002 hexadecimal, then jump L2, and here you used L1 logic. What is the logic? STA 9002 hexadecimal, then move a comma b, then STA 9003 hexadecimal, and after last instruction is halt. So see that after, yes, right. So now assemble and load first. Oh, there's some error. So what is error? Oh yes, right, here L2 is not mentioned, so this is very important. Okay, now again assemble and load. Yes, there is no error. And now insert our two numbers, any two numbers, say for example FF and 56. So we see that here first number is the larger number. So now rate of the solution step by step. Start. Now after operation of this action, we see that first here, but here I have some problem. The problem is that here both are the FF. Why this line is, there is an error or not? I see that this is INXH, I written the code, compare M, GNCL1, and then ST9003 A comma B, ST9002, then jump L2 performance. First of all, the first number is stored in the accumulator, okay, then this is INXH, and the second number located in the HL pointer. So between the if jump, if no carry, that's when the accumulator stored the larger number. And then in the B, oh yes, here some problem arises. Okay, yes, right, there is problem arises because here one thing, we save the number in the B and then we take action performed between the B. Okay, otherwise the result is wrong because the second number is always stored in the memory pointer. So that's why the programming logic is wrong. So what I will do, INXH and then transfer the number in the B and then compare accumulator with B. Now if this condition satisfied, now this accumulator transfer and then B transfer and this is also true for this line. Okay, now see that, is it wrong or not? So programming is very, so how the programming is performed, we see that. Now we see that, yes, log file generation. Now we see that, now this is okay. Okay, now again what we assemble and load. You see that the first larger number and then smaller number. Now second case for the validity of this programming, now we insert 56 and then FF. Now see that simulation process. Now log file generation. Sorry, there are some error. Okay, we come back again. There have some error. Okay, now see that this is assemble and load first. So this is okay. Now we go to the 9000 hex location. Okay, we go to the 9000 hex. Yes, here first we insert 56 and then we insert 50. Okay, now simulate. Start step by step simulation. Now see that the first number is FF and second number is, so these alternate the position, FF and then F556. Okay, actually the error is generated because we increase one most simulation step, so that's why there is a problem in a software. So now here we insert the number again 56 and then FF. Now first store the larger number and then smaller. Now we'll see that. Now very carefully. Yes, that means after this log file, if you increase one more step, that there is a error is generated. Okay, now see that there is a microprocessor frequency, what is the maximum time required, what is the maximum clock cycle is required. Now close this log file and see that This is a larger number and this is a smaller number. Okay, so this is the programming approach of 8085. In the next video, we'll be discuss about the advanced programming method in 8085.